Hello, everyone. Welcome. I'm Kanchana Patlola. I'm one of your co-hosts for the 5 days of AI Agents intensive course. I'm here with Anand Navalgria, who would be my co-host as well. Anand, why don't you go and say hi?
Hi, everyone. I'm Anand. I'm an AI engineer and the founder of this 5 days of AI series. And I'm looking forward to working with Kanch and the rest of the team to give you an exciting live stream session.
Thank you. Welcome, everyone, to the day two Agent Tools and Operability with MCP. And we are super excited to have you all here. Over the past couple of days, we have seen increased momentum in different social platforms. We have seen you learning. We have seen you sharing your key takeaways. We are observing community helping each other in Discord and other platforms. Insightful questions, which gives us a pause. We saw one of the Discord user created an issue documentation in ADK docs, and we were able to immediately resolve it. This is exactly how we want the community to grow, and we are so grateful you're all being part of it. Just as a reminder, it would be very similar to our previous assignments. Every assignment would have code labs, white papers, in-depth white papers, and we would have a podcast summary, and you would be able to choose the medium you would want to learn. There is a capstone course or towards the end that would be launched on day 5, where you could test your building skills, and you would be able to check all the content out on your own pace as well. You don't have to do it live, but we recommend certainly for the community to help each other to be able to test it out. So please do that. As mentioned earlier, there are 3 ways for you to be able to get the content. 1, if you're registered, you would be getting an email. 2, if there is the learning course website, you would be able to access the content from. And 3, the Discord community announcements, we will be posting it every day for the next day assignment as well. As I mentioned yesterday, it is a village. It takes 100 plus volunteers to put all of this content together. I highly recommend you all reach out in the Discord community, where these moderators are active. They are answering your questions. You probably already saw Brenda, Anand, Polong, Sita, Irvin, Eric, all of them posting content, engaging with you. These are folks who are engaged with customers every day, and they are here to help you on your learning journey. So I strongly recommend keep the chat active, keep the conversation going, and we are here to support you on your journey. And this course was designed, like as Anand said, he has done this previously 2 iterations. This is the 3rd time of this event. And AI agents, if I recall correctly, Anand, it was a 1-day agent course. And now we are at 5 days. And honestly speaking, we could still talk a lot more about AI agents. This was a condensed course as such. We start from defining agents, and then we add more color to it. And then we see under the hood, and then we talk about how do you get it functional, and then we release a capstone course. So the course was built to encourage you on your learning journey. I highly recommend you follow the structure so you will get there. Next, today is day 2. And going from your defining the model, how do I add my API key, to adding a tool and giving eyes and the hands to your agent is going to be an exciting journey. But to talk about this more, Anand, why don't you jump?
Thank you, Kanch. Really exciting introduction. And yes, before I go over to the overview of the white paper, I wanted to call out, you've seen some errors of resource exhaustive errors on Discord 429, and that's mainly due to the overwhelming demand, which and we are working to resolve it, and you will hear from us once it's resolved, so it will be fixed. So stay tuned. All right, then to the white paper. So in yesterday's white paper, day 1's white paper, you learned about basic agents and the agentic architecture, the levels of various agents, and the various components of agents. In today's white paper, we will discuss agent tools and interoperability with MCP. And this white paper basically start off by covering best practices for tool design to ensure reliable performance. That is very critical because one of the things that distinguishes agents are tools, the fact that they have hands and eyes to interact with the external world. And further on, we emphasize that tools should represent granular, specific tasks, not just generic API wrappers, and should ideally have crystal clear documentation, because that documentation is the prompt that tells the LLM how to utilize that tool to achieve its task. Then further on the white paper, we address the major industry challenge, as I like to call it, the NXM or N into M integration problem, where connecting every model to every existing tool becomes very unsustainable as it scales quadratically with the amount of models and tools. So, and here's where we enter the Model Context Protocol, or MCP, as it is better known. It's an open standard that solves this by decoupling agents from specific tool implementations. You can think of it much like USB for AI or AI agents, so to speak. Later on, we also broke down the MCP architecture of hosts, clients, and servers, and its core primitives, tools for taking actions, resources for reading external data like files or logs, and prompts for sharing reusable instructions. Finally, we examined the critical new security landscape that is being introduced by MCP. And this is something which would be especially critical in production workloads for enterprises, and anything that goes beyond a demo or prototype would benefit a lot from this. In here, we looked at the unique risks like tool shadowing, where a malicious tool might trick an agent into using it instead of a legitimate tool, right? And then we also looked at dynamic capability injection, where an agent might suddenly inherit dangerous new abilities without the necessary approvals required to use it. And all of this coming together hints towards need for strict governance of the MCP and the agents which use it. So that's a rough overview of the white paper. For those of you who haven't read the white paper yet, I would recommend starting off with the NotebookLM Generated AI podcast, where you get a quick summary, and then diving deep and using NotebookLM to analyze the entire white paper, or just reading it old school from top to bottom. So that's it. We'll be going into the code labs later. Off to you, Kanch.
Oh, thanks, Anand. Now, can we have the Q&A speakers onto the stage? Thank you. Thank you, everyone, for joining. Really appreciate it, despite your busy schedule, taking the time. The community loves it. They want to hear from the industry speakers. We see that in the YouTube live chat. So thank you for taking the time, truly honored. And we have an external speaker, Dr. Alex Wisner-Gross. So thank you. Why don't we start with the intros? Dr. Alex.
Yes, thank you for having me. So I'm a computer scientist and a physicist, and I spend almost all of my time thinking about solving the world's hardest problems with AI. Basically, the thesis is we're on the verge of solving superintelligence to the extent we haven't already, and I think a lot about what comes after superintelligence. How do we solve math, science, engineering, medicine, the world's hardest problems with superintelligence, including with superintelligent agents?
Thank you. We are so glad to have you here to share your thoughts and insights to the community. Thank you. Oriol, thank you for joining.
Yeah, thanks. Yeah, thanks for having me. Yes, I'm Oriol Vinyals. I'm VP of Drastic Research, and I'm the co-tech lead of the Gemini model together with the amazing Jeff and Noam, and been at Google for, I believe, 12 years and 5 days. So glad to be here.
Thank you. It's so great to hear from you all as you were working in the models as well. And folks have been testing incredibly with the Gemini models. Edward, why don't you go next? Thank you.
I am Ed Graffenstedt. I'm a director of research at Google DeepMind in our Frontier AI unit. and an honorary professor at University College London. I've been working in deep learning for NLP before it was cool. I feel entitled to say that because of the hipster stash for November. And I've also been working on agents through the medium of reinforcement learning and more recently LLM-powered agents while it was cool. So I'm really glad to be here to talk about this.
Super excited. And also thank you for working it when it was not cool as well. Thank you. Oh, Mike.
Yeah, thanks, Conch. Really happy to be here. This is such an exciting course to be part of. I have also been at Google for about 12 or 13 years. I'm a software engineer and a computer scientist. I'm one of the co-authors of the white paper that you all are reading. So along with Conch, if you find any errors or mistakes, you can throw them my way. I studied AI at Stanford long ago under some of the leading lights of the AI movement, Sebastian Thrun, Andrew Ng, Fei Li, many years ago. And I've been to Google now for a long time, and I spend most of my time now as a solution architect, helping our customers figure out how to get the most out of our AI technology and build some of these amazing agents that we're all working on.
Thank you.
Very excited to be here with everyone.
Thank you. We are so excited to have you all here, and we are going to jump to the meat of it. Anand, why don't you start?
Sure thing, Kanch. So excited to have you. And Oriol and Edward, the first question is for you two. So we've been thinking, which exciting frontier LLM-driven agents, or can you think, or where are the, which exciting direction are the LLM-driven agents heading towards in the next few years? What do you, in your personal opinion, what do you think? What do you think that these agents can do to help achieve AGI in the next long-term horizon?
Maybe I start since my name is on the left. So yeah, I guess there's two questions there. Perhaps selfishly, where agents are going, definitely very excited to see agents that can start to perform the kind of AI and ML research that we've been performing for many years. So in a way, like agents that do our science is super exciting. I think it's super exciting because that also obviously will enable the acceleration of the Gemini model development, for instance, itself, like by basically automating parts of that process. So that would be quite drastic. I mean, agents is super exciting overall. I think no one sort of would have believed LLM in themselves would be able to achieve AGI. So I certainly believe that LLMs are already evolving to be agents, right? That's the full picture. So the systems that have LLMs as part of their components, but they can be quite much more complex. That's, to be honest, even the original mission or vision that we had in Gemini early days a couple of years ago. And then to the second question for breakthroughs, I think probably finding scalable methods, especially in post-training, I would say. I mean, pre-training has given us a lot, and there's still a lot of progress we are finding and unlocking. But in post-training, reinforcement learning, agents, and all those sorts of things are, in a way, a little bit in its infancy. Maybe if I can summarize that answer, kind of unblocking what we've seen with self-play, but for LLM agents would be, I think that would be like a step change, and clearly working on that very strongly. But curious to hear also what Ed has to say. On to you, Ed.
Yes, thank you, Oriol. I mean, I'm not going to disagree with anything you've said here, and that I think that characterizes my view as well. So maybe to add some color, I got into, when I started working in machine learning, I started working on natural language understanding because I saw language as one of the substrates of human intelligence, and the support for our generality, our ability to reason about the world. But at the time, a lot of what people were doing in natural language understanding and processing were kind of specific tasks, things like sentiment analysis, machine translation, important tasks. Oriol's contributed many seminal works here. but we want intelligence to do things in the world for us. So that led me, very much like Oriol, to look at reinforcement learning also as an interesting domain to build agents. And there it was sort of the opposite problem. Like, it was open-ended what they could do. We could put them in general purpose environments and have them learn to play Go at a superhuman level, to fold proteins. But we always were training them tabula rasa, without sort of leveraging the tremendous amount of information that humanity operates on. We come into a world with context, right? And so it was so exciting when I saw some of the first papers by Google, like LaMDA or Mina, that sort of tried to bridge both of these approaches. Take something that was intrinsically a language model, a sequence model, but interpret some of the outputs as actions, as operations on an external environment. And we've really seen this whole line of work flourish, in particular thanks to the part of the organization Oriol sits in, to have models that are the best of both worlds, that can leverage a tremendous amount of human knowledge compressed into the LLM and act on arbitrary environments that, thanks to protocols like MCP, are almost defined at point of use. So that's already an exciting time to be in. And I could answer the second question by saying, let's see where this goes. But I think there's even broader and more interesting questions here. Like, how can we imbue these agents with a certain notion of self-directedness, the ability to set their own goals, to measure whether or not their goals are successful, with decreasing human involvement and attention, such that they can become truly autonomous partners in our activities and in our society. And I think tremendous amounts of research need to be done to address these, but it's an exciting time to be involved.
Wow, that's very exciting, and I personally love the analogy that we represent our knowledge and intelligence. Knowledge and intelligence through language, and by modeling language good enough, you can transitively model intelligence. So I like the direction where we are heading towards. And thanks a lot, Oriol, the great work on Gemini models, and Edward as well for the work on agents. Okay, perfect. Shall we move on to the next question? Right. So the next question, this is for you, Edward. So we rely a lot on golden data sets for baselining, but given your work on open-endedness, how do we move beyond fixed benchmarks to evaluate true adaptability and robustness to novel situations, like, as you could say, out of distribution situations?
So in some forums, I like to be spicy and say that the age of the benchmark is dead, but we have a learned audience here today that want a bit more sophistication and subtlety. So benchmarks are still important, right? We've spent 10 years sort of trying to constantly develop more and more complex benchmarks for more and more complex and valuable behavior, from can you classify handwritten digits to can I translate Chinese into English passably to sort of can I generate valid Python code at scale. And so we still find a lot of utility for benchmarks. But benchmarks are a proxy for the actual sort of deployment capability we're trying to measure the quality of, right? They're sort of like a guess, usually an informed guess, informed by data and by usage, of what are the sort of things the model and agent are likely to face at deployment time. The problem, and what makes this a delightful area to do research in, is that the actual applications that the agent is going to be involved in at deployment time are now increasingly directed by the user. They're in the hands of the prompt engineer, of the person providing the context, perhaps the MCP server, and no longer in the hands of the designer. So this creates a bit of a chicken and egg or cat and mouse game, where we need to have a source of info. If we want to continue using benchmarks to measure regressions, to model the capabilities to improve the LLMs and other components that underlie our agents, we need to constantly track where the boundary of utility is. Where do we most need to sort of close a gap between machine and human and then exceed it? And the best way to do this in practice is to rely on actual applications, on having people build things. People use this in the real world and tell us or inform us about where there are problems. And so it's wonderful to see a broad community of developers that are trying to build with this, that are trying to build new businesses, new applications and services that will both benefit from the improved models that we deploy time and time again, but in doing so also be perhaps the most reliable and most important source of information in terms of where there are worlds left to conquer. And that's why we're very happy to be partnering with a broad community externally.
Amazing, Edward. I love that answer, because we are covering a lot about real-world applications deployment and evaluation of agentic systems later in the course. So for the audience listening to this live stream, stay tuned. We'll be covering this in more detail. Amazing. Then the next question, please. So this is for you, Oriol. So current protocols require in-context tool definition, consuming valuable tokens, and hindering reasoning. What breakthrough would, according to your opinion, would allow natively handling thousands of tools without this overhead? We had discussed a similar question yesterday, but this is future looking. What do you think can be done in the technology space?
Thanks for the question. I actually would probably challenge the question and would actually want to turn it around a little bit. Because actually, if you think about the ability for the model to follow instructions, to do in-context learning, I mean, these are both critical features of intelligence, and we would definitely want to see the models being very good at this on our quest to build AGI. So I think defining like more of these tools in context, I actually think is a feature. Now the question or the challenge is, how to make this context management more efficient, right? Like more than a year ago with Gemini 1.5, we broke the 10 million token length, context length. But of course, we haven't stopped, right? We are working hard to make context on the one hand even longer, and on the other hand, cheap, free, basically, if possible, and super fast, right? So hopefully you can define these tools in context and not suffer from what the question alludes to. And then, I mean, at the same time, maybe some tools that are very core, that should always be accessed, maybe they can be absorbed into the model weights. But I actually think, especially as a developer, as this tinkering with the model, it's great that you put something in context and the model pays attention to it and truly learns and does what you're asking it to do. So maybe the challenge for us is to make longer context, cheaper, better, etc.
Absolutely. In working with real applications with customers, I love the performance Gemini has, even in very long contexts, which is something, so it kind of changes the way you think about things, and you can stuff a lot of tools. That's great. Great answer. Thank you. Thank you so much, Oriol. Then let's go on to the community questions. Kanch, would you like to take that over?
Sure. So this is from community questions, Neha, for Mike. Mike, how do you ensure reliability and error handling in tool chains where one tool's output becomes another tool's input, given that agents are expected to behave unexpectedly?
Yeah, thanks, Kanch, and thanks for the question. It's a great question in the agentic context. As the question points out, agents can and often do adapt and respond unexpectedly. So the first thing I would say is that agents are a tool, but make sure you're using the right tool for the job. There are more than one tool for writing workflows, and if it's really important that you have a deterministic workflow that proceeds from A to B in sequence and gets everything right, it could be that an agent is not the right tool. There are workflow tools and you can write a deterministic workflow in many tools, and this is how we've been programming for years. So look into this first of all, and check that the agentic context is really what you want for this use case. Another thing to think about if you are writing in an agentic context is tying the input and output together using schemas. So in our open source framework, you can define an input and an output schema to each agent in the flow. If you use that schema approach, you can provide a better guarantee for the consistency of the input and the output of each stage in the workflow. So that ties the pieces together in a more consistent way. And the third thing I would add, another thing to add, four things. Another thing to add is again, there are also deterministic workflow agent types. Again, in some of the frameworks like ADK, there are agent types that are deterministic, not based on an LLM output, but you can use those to actually find a programmatic workflow that also gets tied into an agentic context. So you can use them in the context of a broader multi-agent system, but they provide that kind of deterministic guaranteed workflow steps that you can rely on. The final thing I wanted to add is you can also remember that the error output from a tool is also an instruction to the agent. So if an agent replies, if a tool step fails and returns an error, you can use the error output to provide instructions back to the calling agent about what to do in case of that error. So that's often something that's overlooked in developing these multi-agent systems, but use every piece of information you have and every piece of documentation you have to give instructions to the agent as to what to do and how to handle error conditions or failures or retries, and instruct it on what to do in each of these cases.
Thank you, Mike, and thank you for the 4 pointers. And I believe you did discuss this in the white paper, with the best practices of the tool design. What would be the best approach to be able to
right? Some of those are in the white paper there, especially the point about documentation. So yeah, those are key best practices that we go into more detail about in the white paper.
Thank you. So now back to Oriol from Rashi Tyagi. Do you see model training evolving to include simulated tool use episodes rather than learning tool use purely from prompting and schemas?
Yeah, thanks for the question. I think a bit related to the first question about what breakthroughs, right? I think if we unlock through self-play, curriculum learning, etc., then we most certainly, I would expect, right, that the model in some form, right, it will have to come up with their own tools, new tools, variations, combinations, etc., as they train, and perhaps, then there's a dilemma whether tool use are an artifact of the current model limitations that might be removed and eventually absorbed into the weights of the model, right? But certainly you could, have a world model in a way of every tool eventually if you train for a very long time. And so that simulation might be a step towards actually the removal of needing the tools. But personally, I would bet against that at the moment. I think, tools are great. They're abstracting and in a way, it's kind of how we think about like reusability of software and so on and so forth. So I wouldn't bet against that, even if because of our own biases as the creators of the technology. But certainly we would expect, as we train and as we evolve our, in a way, tool use is kind of an agent is like the newest modality. Like it's not that mainstream for that long as vision has been, or audio, or of course text. So there's a lot to discover, but certainly these kind of techniques that would make the model either discover new tools, simulates new tools, and so on, I think are probably a key ingredient to the scalability limitations of post-training that I was discussing earlier. So yeah, great question. Maybe try some ideas during these 5 days and beyond, and if something works, let me know or let us know, and maybe we'll work together.
Yeah, and so that might be an exciting capstone project idea for those of you who are listening.
I was going to say, so this is exciting, and you have certainly increased curiosity in others as well. So thank you. And as models become more agentic, these are things which we all need to be aware of. Appreciate it. So the next question is from Brian. I'm not even going to try the rest of the numbers. If MCP succeeds in standardizing how AI agents interact with tools, could it eventually lead to an internet of agents, a decentralized mesh where autonomous systems trade data, services, and even goals? What would governance look like in that world? Dr. Alex, this is for you.
Yeah, I love that question, but I also think we're likely to find ourselves in the near future where the boundaries between agents more or less trace liability, informational governance boundaries that we have in existing social systems. So one could imagine a near-term future where the ratio between humans involved in productive economic activities and the number of agents just gets fully diluted. You have humans overseeing vast fleets of agents, in which case the limitation for agency of individual agents in those fleets is less about capability, which is sort of where we are right now, and starts to look a lot more like liability, where ultimately the limitations on the free agency of AI systems is limited more by what is the minimum number of natural human persons that can oversee them and be ultimately legally, ethically responsible for their behavior. So that's the first thought. The second thought is, I guess also the elephant in the room, something I think about a lot, is how many agents want to exist in an enterprise environment that is fully observable internally. So if you imagine, just as a thought experiment, an enterprise where there are no internal informational boundaries, and obviously in the fullness of time, we would like to, I at least would like to see enterprise work fully automated. Does that setting want to be a single agent? Does it want to be a million agents? Does it want to be 0 agents? I would argue that in the limit, we want a single, at least internally, fully observable enterprise to consist of exactly 1 agent, because agents ultimately, if there's only one outer boundary of sort of corporate personhood in an enterprise and no internal information boundaries, we want one very strong singleton agent that doesn't have to hide information from various subagents. And as Oriol, I think, very eloquently pointed out earlier, ultimately, one of the reasons why tool use is attractive in the long term is as abstraction. So in my mind, the question's, I guess, jumping up a few levels, less about do we find ourselves in an internet filled with agents interacting autonomously, and more, do we saturate corporate personhood as it's currently construed with approximately 1 agent per corporate person, assuming no internal information boundaries?
That's definitely thought-provoking because we have been thinking about, A2A with agent-to-agent protocol, and also adopting agent with MCP inside, and when to use what would be the recommendation. But thinking of it with Internet of Agents, particularly a singleton agent, is certainly something for our enterprises to consider. Thank you, Dr. Alex. So the next question is from Dablina Carr. How do you design a multi-agent communication protocol that safely coordinates concurrent tool calls in a single query while resisting prompt tool injection? Mike, why don't I start with you, and then I'll go to Dr. Alex.
Sure. Yeah, that's fine. So the way, it's a security and coordination and resisting prompt injection, tool injection. These are really important questions for the agentic paradigm, and particularly around MCP. We talk a lot about these in the white paper. I look at this question as really asking about how do you design a multi-agent system that addresses some of these issues and manages some of the threats and risks that are being introduced in this paradigm. Alex just made a really interesting point about having a singleton agent, and I think part of the dynamic here that we have in the development of these agents is, from one perspective, an agent might present a single interface and a single conversational interaction with the user, and in that would represent a single agent. But under the hood, it can be built and composed of multiple agents that are contributing to that output. So it may at the same time be a single agent and a multi-agent system. In designing a multi-agent system that coordinates this way, I think one of the things that I mentioned before is also really important here, which is constraining the inputs and outputs of each of the agent in the system through the use of schemas. So matching the input from one agent to the output for another agent by constraining the schema that limits the possibilities of risky or kind of unwanted output or input from any of the components programmatically. Another part of this, though, really important in this paradigm is trust, and the trust between each of the subagents that are part of these systems is very important to establish. So, for instance, trusting your tool sources. Tool injection arises when an MCP server or another tool source is able to present a tool that wasn't expected. So, as you're composing a system like this, ensuring that you trust the operator, the maintainer, the system that is generating and presenting the list of tools to your agent is critical. Access control also is another really important point, making sure that the tools know how to trust the user, and the trust is propagated from the user through your system, through the tools to the end, to the whatever data source or system is being accessed. So again, propagating the trust through each of the components in the system is super important. And another thing to add is that there also is in the MCP protocol, for instance, there is the option that's often recommended for some of these the capabilities of using a human in the loop capability. So popping that action or question up to a human operator and bringing in the human in the loop for sensitive operations, that's an option that's available and recommended as part of many of the components of the MCP protocol. So those are three mitigations that I certainly would recommend here. But I'd love to hear, Alex, your thoughts on this too.
Yeah, no, I think it's a perfect description, Mike. I would maybe jump up a few levels and suggest that the question seems to be separable into two separate sub-questions. One is the issue of concurrency, and without sounding overly glib, I think that's more or less an engineering problem, less of a research problem. But the other half, which is, I think, about prompt injection via MCP calls, that I think is profoundly interesting insofar as historically, before the modern generative AI revolution, we would have treated prompt injection as just an engineering problem. There are best practices to fully mitigate code injection. You can use regular expression matching. You can use templates. Lots of tools to basically guarantee 100% security against prompt injection. Now, though, now that we're in this unstructured natural language world where machines understand completely unstructured data to a great extent, I think prompt injection turns from just a simple engineering problem into arguably one of the grand challenges of AI and machine learning that probably, again, in the fullness of time, requires some degree of self-reflection. I would treat prompt injection from MCP calls as a special case of a more general class of poisoning attacks against autonomous systems. In this case, poisoning attacks introduced in context via return values of MCP calls. But if you think about it, like what in the fullness of time, when superintelligence is maybe not fully solved, but we've made a lot more progress than we have right now, what does the solution to prompt injection look like? I would suspect it looks like autonomous systems that are able to introspect into their internal activations or whatever internal activations evolve into, and are able to recognize that they're being steered in some sense through their input stream. That level of self-awareness, I think we're only starting to see the glimmers of that out of frontier labs, including DeepMind right now, but I expect to see much more self-awareness as a defense against prompt injection in the future.
Just wanted to add to this that the part of at least evaluating tool use and prompt injection involves agentic evaluation, measuring how agents, like evaluating the overall performance of agents, and that's what we will also be covering in later days. So stay tuned.
Yeah, and some of the security as well. But those are like great points, and thank you for sharing all of your insights. It would be great to hear from you, like what final thoughts for the community, what you would like to share. So Edward, you are in my screen in the end, so if you would like to go first, if there's anything you want to share to the community.
I mean, just maybe to reiterate some of the points, like one of the two following things is true. Either we have all the ingredients for superintelligence and we just need to scale them, or we don't. And to determine which of these two situations we're in, we basically need to see where the limits of the capabilities of agents built on this technology lie, or whether we hit a wall. And if we do hit a wall, we have been doing research. We can continue to build exciting technology that will service humanity. But you, as builders, as people using this technology, play an integral part in this. The more you try and develop complex use cases and agents, the more you try and demonstrate the economic and personal value of this technology in things that matter to you, the more we will understand where the limits are or whether or not we're off to infinity.
Thank you, Edward. Appreciate it. Oriel, why don't you go next?
Sure. Yeah. I mean, lots of thoughts during this Q&A. So maybe the one that maybe to re-emphasize is this evolution of the technology, like meaning maybe more generically machine learning, right? So I think we've seen general algorithms like stochastic gradient descent and neural networks applied to relatively narrow problems like Go, AlphaFold. That evolved through large language models that did language only. Then we added more modalities. So these models became extremely good at also understanding images, sound, videos, etc. And I think a next stage of evolution, which we're starting to see, and I mean, if you're obviously, I think it's here to stay for a while, perhaps all the way up to AGI, is this scaffolding around these amazing, powerful models with all the interesting questions that comes with that. So I think the agentic kind of era has started, and it builds on top of many things we've seen before. So either you're new and add a lot of energy and creativity. If you maybe have been around for a while, understand the big picture, bring back some of the old ideas that oftentimes are very successful. And yeah, looking forward to seeing what the whole community really builds on top of the models and the agents and beyond.
Thank you, Oriel. Appreciate your insight, particularly the word scaffolding. I think I'm going to keep using that from now on. Thank you. Mike, you are on my screen next.
Yeah, sure. Well, I would just say I think this is a really exciting time. I spend a lot of my time really in the trenches with customers, helping them build their agents today and see what's working and what isn't. And often I spend more time thinking about what isn't working and what agents are not able to do than what they are able to do. But a lot of the things that I've seen them agents do out of the box are really impressive, and they give me a lot of hope and a lot of kind of excitement about where this is going and what we're able to do here. But I also want to say, let's as we're developers, we're talking to developers and engineers here on this call. Remember to think about what agents can do and what they can do, and think carefully about when you should and shouldn't apply them and what their right use cases are.
Thank you, Mike. Limitations are really very much important, and I think you and I are living and breathing that. Dr. Alex, last but not the least, thank you. Any final thoughts?
Two thoughts. One, thank you for inviting me to join this amazing event. And the second thought is I spend, as indicated earlier, almost all of my time thinking about what comes after superintelligence. I think there have been some amazing points articulated here already regarding how we get to superintelligence, to the extent we're not already there to some extent already. I think about what comes afterwards. And I think what comes afterwards is solutions to some of the hardest problems in the world. And I would just love to engage with the community. If there are folks in this amazing community that are also interested in solving the hardest problems with agents, I would love to connect with them.
Thank you, Dr. Alex. And thank you so much for your time. All of you spending your time talking with the people and also welcoming their ideas. I think that is what we want this to be. And we are really looking forward to see where all of this is going to take. And I am actually tempted, Anand, to do a capstone myself to see, hey, I put my chit in. So thank you very much.
This is for the community lunch. We do keep it for the community.
So we would love to bring me in check.
We would love to see some of the ideas and thoughts presented here. If it reflects in your capstone project, or as much, or you can tackle some of the challenges like many use? How do you go beyond like putting or how do you like putting all the tools in the context window, or you try putting as many tools in the context window to see how you can come up with more creative solutions and prompt injection, tool injection? I would love to see all of this in the capstone to see what creative solutions you come up with.
All of the questions can be a capstone. So we are really looking forward to see. And as Dr. Alex and others have Oriel have also mentioned, please do, if there is a creative idea, we would love to see it. So thank you to the speakers. We are truly honored to have all of you here. We are super excited to see how the community is going to build. Thank you.
Thank you.
Thank you, everyone. Thanks. So now, most of you have already, experimented with Code Labs, and we have been seeing a lot of comments. Before we bring up Lakshmi, I do want to see where in the community you are all, where in the world you are all from. Yesterday, we saw a lot of pop-ups going, and it was hard to catch up. So thank you for the folks from wherever you are joining from. You are amazing, particularly folks who are, doing off hours, trying to catch up your work, making this work. We are really thankful for your time. Lakshmi, why don't you come on stage?
Hey, Kanch. Hello, everyone. Welcome to day 2. So yesterday, we learned how to create agents with powerful built-in tools like Google Search. And today, we are going to take the next step. So I hope you are all ready. So we'll explore today how to build the custom tools, delegate to specialist agents, and handle the kind of real-world complexities that you will face in your own projects. So the advantage of built-in tools like Google Search is that you can use them with zero setup. But what if we are building agents to solve your specific business problems? This is where custom tools come in. They are exactly what they sound like. The tools that you build yourself using your own code and your own business logic. They give you complete control. And if you know how to write a Python function, you already know how to write an ADK tool. Create a standard Python function, add it to your agents tool list. That's it. You have created an ADK tool. Now, let's think about a real-world problem. When you're traveling to a different country, one of the most important tasks is to find out how much local currency you would need for your trip. And this involves multiple steps. First, we need to find the transaction fees associated with the exchange. And depending on whether you're using a credit card, a debit card, or a bank account, these rates vary. Next, you need to find the current currency exchange rate. And then the most important step, perform precise calculations so that you will have enough money when you reach the country. Awesome. So what if we could build an agent to do this? And today we are going to do exactly that, build a currency converter agent. We start by defining 2 Python functions, get fee for payment method and get exchange rate. And then as a next step, we add them to our agent as tools. Fairly simple, right? But here are some tips. When you write these functions, always make sure to include doc strings. Also, make sure that you have dictionary returns. You can read more about this and other best practices in our white paper. So the next step I told you is to add these functions to the currency agent. And once we do that, again, there are a few points that you can keep in mind here. Use the precise function names in your instructions. This helps removing ambiguity about the tools to call. Awesome. So is everything done? Is that it? Unfortunately, no. Because sometimes the LLM can make mistakes in calculations. So what could happen here is that it might use a wrong formula for calculation, or it might use the right formula but do mistakes while doing the calculation. and how can we solve it? What can we do? So let's instruct the agent to write and execute a Python script for doing the arithmetic. And we do this by creating a specialist calculation agent, which uses the built-in code executor tool to do this. Awesome. So what is the next step? That is to add this calculation agent to our currency converter. So for that, we are defining a new agent called enhanced currency agent. And we do two steps. One, explicitly tell the agent that you are prohibited from doing any arithmetic calculations yourself. And instead, use your calculation tool to do everything that you need when you see numbers and calculations. Awesome. Done. And then what next? Next is to add the calculation agent as an agent tool here. Now, when we run a query for a conversion from a US dollar to INR, you can see that in the code that the enhanced currency agent is able to transfer the calculations to your calculation agent, which in turn generates the Python code for getting the answer. But wait, what is this agent tool, right? So yesterday we talked about sub agents, but what is an agent tool? So this is a very key point that you need to keep in mind. So when agent A calls agent B as a tool, then the B's response goes back to A, but still A is in control. By this, what I mean is that it is still agent A, which is talking to the users. But if you define B as a subagent to A, what happens over here is that A transfers the control to B, which then does its tasks. But also from that point on, it is B which is talking to the user and not A. So depending on your business scenario and your requirements, choose either the agent tool or the sub agent. And with that, we come to the end of the first notebook. So we have provided links to the other built-in tools and custom tools that you can experiment with and build your solutions for the Capstone project and otherwise. And next, we start looking at the MCP tools and long-running functions. And for that, I need to switch my notebook. So give me a second. Awesome. So we are on notebook 2 for day 2. So last notebook, we built custom Python functions. Now, let's kind of think about the real world problems that we have. Suppose we want to connect to external systems like GitHub or Slack. So how can we do that without writing custom API clients? And second, how do we handle tasks that aren't instantaneous? For example, tasks that might need to pause and wait for a human decision. We are going to solve these with two very powerful patterns, MCP and ADK's built-in resumability features. So let's start with MCP, or the Model Context Protocol. This is an open standard that lets agents connect to community-built integrations, thereby avoiding the need for custom API clients. It works by connecting your agent, the MCP client, to external MCP servers using a standardized interface. This enables scalable access to live data and tools from diverse sources. So using MCP is very simple. It's just a 4-step workflow. Choose your MCP server and the tools that you want to use from within the server. Then create the MCP toolset by configuring the connection. And once that is done, simply add the tool to your agent and you're ready to run and test it. So in this notebook, what we have done is we are using a Everything MCP server. This is an NPM package designed specifically for testing client integrations. While it's not meant for production use, it's perfect for learning because it exercises every feature the MCP protocol provides, the prompts, the tools, the resources, and more. So we'll be using a get tiny image tool from this server. Awesome. So first step, we configure the connection using the MCP toolset. And once that is done, we add it as a tool to our image agent. And then when we test with a prompt like provide a sample tiny image, what happens is that the agent automatically calls the tool and the server returns an image. And we can print out this image. So that's what you see here. It's a tiny image. It's just a 16 by 16 image. Cool. Awesome. And there is also a Kaggle MCP server, which is available, which helps you to connect to the data sets and competitions. So what I want you to do is, build an agent and use this Kaggle MCP server as a tool and run queries like, listing data sets that have, say, OCR data. And let us know how it goes. Now to the second part, the human in the loop for the long-running operations. So standard agents are designed for speed, right? They call a tool and they expect an immediate answer, but that doesn't work in real life. So you often need to say that, okay, wait, this is a big decision and I need a human to sign off on this first. So let's kind of build a shipping coordinator agent to show you what exactly I mean. The first step, as always, is to define a function, in this case, the place shipping order. And here you will see that this function has a parameter called tool context. So this is the secret of long-running tasks. It gives your tool two essential new capabilities: the ability to pause execution, to ask for approval, and the ability to check what the human has actually decided. So there is also a workflow over here. So here you can see that if it's a small order, there's an auto approval. But if the order is large, then the request confirmation is called. And whenever the human approves, the agent kind of makes a decision based on the human's input. Awesome. So next we create a shipping agent and then add this tool. But wait, there's a catch. Standard agents are stateless. If they pause, they forget everything: who the user was, what they wanted, where in the flow they were when they paused. To fix this, we wrap our agent in an app with the resumability config set to true. This crucial step ensures that when it pauses, the entire state is saved to a persistence layer. Awesome. So if you kind of scroll down to the section 4.5, you will see that we have provided 3 demos, one for each of the scenarios that we talked about. So I highly encourage you to kind of change some values out there and test them out. And with that, we come to the end of day 2, where you have added 2 new massive superpowers to your toolkit. One, MCP for standardized integrations, and long-running operations for reliable human-in-the-loop workflows. And tomorrow, we are going to go even deeper into session, state, and memory. And I'm totally excited about tomorrow. And thank you, everyone, for listening in. And back to you, Kanch and Anant.
Thank you so much, Lakshmi. And I tried the code labs. I have to say the instructions are very detailed. I would suggest the learners to not skip the instructions and just run the cells. It was really important because I skipped it for day 1. And the Google search was not in the ADK web UI, which was intentional, but I didn't know about it. So thank you, Lakshmi, for creating and walking through. Great job. And we are looking forward to see how everyone is going to be, testing it out and coming up with problems and challenges. So tag Lakshmi in Discord. She's there to answer your questions and she will be there for you. So on to our last piece, Anand. This is the most exciting thing because as I see folks answering, this is the POC quests. And Anand, why don't we take a moment?
Yes.
Go over. Sorry, my slides are not moving. Okay.
Yeah. So hi everyone. Get your pencil and paper ready, and you put your thinking caps on. We will test now, or you will test yourself, the knowledge of the white papers that you have read, and the day 2 white paper specifically. So let's get to the first question. What primary problem was the Model Context Protocol, MCP, designed to solve? This one should be an easy warm-up question. The options are A, the high latency of LLM inference in production, B, the N into M integration problem between varied AI applications and external tool systems, C, the lack of standardized benchmarks for agent reasoning, or D, the difficulty in managing long-term memory for agents. So on a count of 3, we'll show the right answer.
Answers popping up.
3, 2, 1. The answer is B. So if you've been listening, even if you haven't read the white paper, but if you're listening to the Q&A, we discussed a lot of these things, including benchmarks and into M. So you should have the answer. That was the warm-up question. It only gets more difficult from here. Let's go to the second question. Which of the following is not one of the 3 core architectural components of MCP? So not one of the 3 components. The options are A, the host, B, the client, C, the server, or D, the gateway. So take a couple of seconds to think.
I see some wrong answers though.
Yes, but I still see some people got it right. So 3, 2, 1, and D. Gateway is not one of the architectural components of an MCP. All right, off to the next question. So the next question is, in the context of MCP, what is a resource? Your options are A, a resource being a function that the agent can execute to perform an action, or B, is it a standardized way for a server to provide contextual data like log, files, database records to the host application, or is it C, a reusable prompt template provided by the server, or maybe it's D, a client-side capability that allows the server to request an LLM completion. So this one is a bit tricky, but if you read the white paper, I'm seeing some of you have guessed it. But yeah, let's show the answer in 3, 2, 1. The answer is B. So that's what the resource is.
I just wish they have one common taxonomy across all of these because it just gets confusing.
Yes, we come up with a lot of technology, so it's good to be confused sometimes. Next question. So talking about confusion, what is the confused deputy problem in the context of MCP security? Your options are A, when an MCP server crashes because it receives too many simultaneous requests. This might be something which is happening in your notebook right now, so we are working on fixing that. Yes, or B, when an AI agent with legitimate permissions is tricked by a user into performing a harmful action with a highly privileged MCP server, or C, when multiple agents try to use the same tool at the same time, causing a deadlock situation, or D, when a user cannot distinguish between an AI agent and a human operator. So your options are, your answer would be shown in 3, 2, 1, and show the answer. So confused deputy is B. So when tricked, an AI agent is tricked. By the way, D goes more into the Turing test. So hopefully you eliminated that option from your list quite quickly. So let us move on to question number 5. The question is, what is the recommended transport protocol for remote MCP client-server communication? Your options are A, standard input-output, or B, WebSockets, or C, streamable HTTP, or D, gRPC. So think about it, and the correct answer will be shown in 3, 2, 1. So the correct answer is C. All right. Well, thank you for joining, everyone.
I see a lot of answers there. So thank you so much for, connecting with us through PopQuest. We definitely enjoy doing this. So thank you for being here. And for folks who are watching live stream or on demand after, we really appreciate it. And we do see the comments in the live chat and in the Discord channels. So please continue to keep engaging with us. And see you tomorrow with a fresh set of curriculum with day 3 context engineering sessions and memory. And this is one of the most requested topics. So we are looking forward to having you all with a fresh set of speakers as well. Looking forward to seeing you here tomorrow, same time.
Thank you, everyone. Same time, same channel. And don't forget to put your questions for day 3 in the Discord channel in the thread that Brenda created. All right. Take care, everyone. Bye.
Thank you. Bye.